With the use of computers, we started to store data into files, then databases with the likes of SQLDB and Microsoft SQL databases. Then moved on massively parallel processing databases like Teradata. But with the advent of digital boom, data size increased, and it increased a lot beyond the capacity of existing databases. At the same time, the need of analysis on such data arises. Here we can classify multi-structured data into structured and structured data. Social data from Facebook, Twitter, YouTube or web blogs comes into the category of unstructured data, while traditional databases, OLTP and data stores comes under the structured data. Right now, 80% of world's data is unstructured. Let's look at some aspects like what is happening in 60 seconds of Earth, where thousands of searches, millions of tweets, and terabytes of data is being created or being processed. So if you look at the data growth forecast, it is increasing 44 times over a decade, which is enormous. In 2009 to 2020, we are seeing around increase into the data forecast by 44 times. Currently, there are challenges with electronics. Once more said that number of transistors will double every 2 years, but that is not happening. We have reached maximum limit of disk drives, CPUs and RAM. With speculation, if we go beyond, will it be cost effective is the question. It means electronics has its limits, cannot go beyond nanotechnology. If it, will it be cost effective? To fight with these challenges, we come up with scale-up concept, where we can increase the capacity of machine with bigger capacity. But it comes with expensive hardware, proprietary software, and vendors lock-in period. We challenged it with the scale-out concept by using multiple machines to increase the capacity with open source software. At the same time, on the other side of the world, RDBMS was struggling with its own challenges of handling petabytes of data, normalization with respect to large datasets, and its inability to handle unstructured data. To address those limitations, it comes the era of distributed computing, where we connected different machines together and divided large problems into chunks and solved it concurrently. Grid computing is one of the examples of distributed computing. So if you look what we have achieved with distributed computing, you can look at the following example, where we were used to take 23 days to sort 100 TB of data on one machine. Now we can achieve the same in 33 minutes by using thousands of machines concurrently, which is huge improvement. But distributed computing too has some challenges like task dependency, concurrency control, data synchronization, state management, etc., and which were obvious. To address all things, here it comes the idea where challenges of distributed computing were completely addressed, which is known as Hadoop. So, Hadoop can be defined as an open source framework for storing, processing, and analyzing massive amounts of multi-structured data in a distributed environment.